Hello YouTube fam. Welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will look at Fine Tuning Ultralytics YOLO for fire detection with help from Roboflow. In Step 1, we will generate forest fire images using DAL. In Step 2, we will convert downloaded images to JPEG. In Step 3, we will upload images to Roboflow. Roboflow is a company that provides tools for building, deploying, and managing computer vision models. It offers services such as dataset management, annotation tools, and model training and deployment support. Roboflow aims to streamline the workflow for developers and researchers working on computer vision projects, making it easier to create and scale machine learning models for image and video analysis tasks. We will do manual annotation, we will add labels and add bounding boxes. Finally, we will train Ultralytics YOLO model. Ultralytics is a company that specializes in developing state-of-the-art machine learning models and software, particularly for computer vision tasks. They are best known for creating the YOLO, You Only Look Once series of real-time object detection models, which are widely used in various applications such as autonomous driving, surveillance, and medical imaging. Ultralytics provides tools and frameworks to help developers build and deploy efficient and harming computer vision solutions. In the end, we will use the finely tuned model for prediction on test images. We thank Roboflow and their contributing writers, especially the Roboflow blog, aerial fire detection with drone imagery, and computer vision. In Step 1, we will generate forest fire images using DAL. Some of the prompts used are: create images of forest fire from drone view from upwards. The view should be from top down. The fire should be in one places in the image and not the entire image. Fire should be just small to medium. In Step 2, we will convert downloaded images to JPEG. We will do from file import image. We will then do img.convertRGB. In Step 3, we will upload images to Roboflow. We will do manual annotation. We will add labels and bounding boxes. We will split images to train, test, valid datasets. In Step 4, we will install packages. In Step 5, we will download dataset from Roboflow. Remember to set up API keys. In Step 6, we will train Ultralytics YOLO model. We will use Ultralytics YOLO 8M model. We will call the model train function. We will provide data.yaml and tune for 35 epochs. It will take a few minutes on T4 GPU. In Step 7, we will run prediction on the test images. We will set model path to the best weights. We will set source path to point to our test images. We will then load the YOLO model. Next up, we run the prediction using the model predict function. All right, finally in Step 8, we will display predicted images. As we can see, our fine-tuned model has predicted fire in our test images and predicted bounding box coordinates as well. We also display the confidence level. If we like to have better predictions, we can use an input data set with varied features. We can also train for more epochs. In Step 9, we will look at an alternate way for prediction using Roboflow Supervision. We install packages like Roboflow Supervision and Ultralytics. We will now run prediction and user supervision for detection. We will set model path to the best weights. We then get results by passing the image to the model. We can get detections using the function SV, detections from Ultralytics. We will now draw the bounding box. We will use sv.box annotator with specified color and thickness. Finally, we will draw the image using svPlotImage function. So that's it, folks. We looked at Fine Tuning Ultralytics YOLO for fire detection with help from Roboflow. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning and algorithms. If you found this video helpful, don't forget to hit that like button. Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.